right, we've already talked about how to convert standard into scientific notation and vice versa, but now let's talk about how do we use scientific notation? How do we add, subtract, multiply, and divide numbers that are already in scientific notation? So this is kind of going to be maybe like a guided, we're going to basically translate the numbers into standard form. We're going to perform the operation, and then we're going to translate them back into scientific notation, and then we're just going to see what do we notice. Can we come up with some rules so we don't have to go through this process each time, so we can just keep it in scientific notation, do the operation. So what do we notice? Can we come up with some rules? So let's go ahead and try this out. Let's talk about addition first. Here we have 3 times 10 to the 6th, and we want to add 5 times 10 to the 4th. Well, let's just go ahead and rewrite these into standard form. 3 times 10 to the 6th is 3, followed by 6 zeros. And 5 times 10 to the 4th is 5, followed by 4 zeros. So 3 million plus 50,000 is 3,050,000. Okay, lovely. What is that back into scientific notation? Well, that would be 3.05 times 10 to the 1, 2, 3, 4, 5, 6 times 10 to the 6th. Okay, what do I notice about that and that? Let's go on to this one and see if we can notice anything from this before we make a conclusion. I have 4 times 10 to the negative 3rd plus 2 times 10 to the negative 3rd. I do notice that these exponents are the same, whereas in this case, the exponents were different. Let's see if that makes a difference. Let's see, this becomes 0.00, let's see, 4, 1, 2, 3, 1, 2. Like that. And this becomes, let's see, 2, 1, 2, 3, 1, 2. Okay, and so then when I add them, well, that just becomes 0.006. Now let's go ahead and rewrite that back in scientific notation. That would be 1, 2, 3. What do we notice there? Can I make a conclusion about how I add things like that? Let's see. Well, in this case, I add 3 plus 5, 3.05. Well, my final answer had the higher power. Okay. In this case, my exponents are the same, and all I had to do was add my leading digits and then keep the power. So when the powers are the same, so I'm going to put same exponent. Exponent. When I have the same exponent, all I have to do is add the leading digits or subtract. Well, we're doing adding right here, and keep the same power. 4 plus 2 is 6. The power is 10 to the negative 3rd, so it's 6 times 10 to the negative 3rd. And that works when we have the same exponent. If I have a different exponent, what do I do? Well, I know that my final answer is actually going to have the greater power, because this is a bigger number adding to a smaller number. My final answer is going to be the bigger number since I am adding them. So I know that my answer will have the larger exponent or the larger power. So that's something that I can kind of know. So can we describe a shortcut? It's always nice to have a shortcut for adding numbers in scientific notation. When they're the same power, it's going to be really easy. I'm just going to add my digits and keep the common power. When they're different, that's a little more challenging, but we could write the numbers with the lower power. in the same but the lower power. And then we can add them and keep the common power, keep the common exponent. And we might have to adjust if we need to. For example, with this one, instead of saying 3 times 10 to the 6th, I could rewrite 3 times 10 to the 6th as 10 to the 4th, because I would like to have a 10 to the 4th and a 10 to the 4th using that lower power. So 3 times 10 to the 6th becomes 300 times 10 to the 4th. So that's the same. And then I'm going to add to it 5 times 10 to the 4th. Now I have the same power, which is nice. Now I can just add my leading digits. That's 305 times 10 to the 4th. And then if I need to adjust, I can. I know that I cannot write this as 305. My number has to be between 1 and 10, so I'm going to move my decimal place over. So that becomes 3.05 times 10, and I move my decimal place over to the 2 places, so I need to add 2 places to my power. So 4 plus 2 is 6. That's a little messy, but oh well. So that's kind of a shortcut for adding numbers in scientific notation. It's very easy when their powers are the same. We have to do a little bit more when their powers are different. Let's go ahead and do subtraction. Let's convert these to standard form, and then we'll subtract and see if we can notice anything and see if we can come up with a similar shortcut. All right, so 7 times 10 to the negative first is 0.7. 5 times 10 to the negative 2, I'm going to move that over 2 places, and that's 0.05. And that answer is 0.65. Okay? Which becomes 6.5 times 10 to the, I'm going to move my decimal place over this way. That is, I had to move over 1 spot. So how could I get from here to here? Let's see. I do know that these exponents are different. Oh, these exponents are the same. Let's see if that one is a little bit easier. 6 times 10 to the 4th, that's 6 followed by 4 zeros. 2 times 10 to the 4th is 2 followed by 4 zeros. 60,000 minus 20,000 is 40,000. And that becomes 1, 2, 3, 4. That's 4 times 10 to the 4th. All right, let's see. What do we notice here? What do I notice here? -1, -2, and my answer is in -1. That's the bigger power, because -1 is bigger than -2. So it's keeping the bigger power. Oh, kind of like the same thing that we had over here with this. When we were adding, our answer had the larger power. What about this one? When I have the same power, my answer has the same power. Interesting. So when I'm subtracting, I just subtract my leading digit and keep the same power. Interesting. So when I'm subtracting things with the same exponent, what do I notice? Well, in my answer, the power stays the same. So 10 to the 4th, 10 to the 4th, my answer is in 10 to the 4th. Well, that's interesting. And when I have a different exponent, let's see, here I had -1 minus a -2, and my answer had a -1. My answer is going to have a greater power. So my answer will have a greater or larger power, which means it's farther right on the number line. So let's figure out, can we come up with a shortcut for subtracting numbers in scientific notation? It's going to be pretty similar to what we had for adding. Let's see. If we are basically subtracting the same powers, well, that's nice, because we just have to subtract the leading digits. 6 minus 2 is 4, and then just keep that common power, 10 to the 4th. So that's nice. But if they're different digits, we can do the same thing that we did here. Write our numbers in the same power, and I'm going to say the lower power. and then we can just subtract them. Subtract our leading digits and then keep the common power. And then we might have to adjust if necessary. So for example, with this one up here, I want to rewrite 7 times 10 to the negative 1 as a lower power. So that would be 70 times 10 to the negative 2. And then I'm going to subtract this 5 times 10 to the negative 2. Now that they're the same power, now I can just subtract my leading digits. So 70 minus 5 is 65. And then I'm going to keep that common power times 10 to the negative 2. But now here's where I'm going to adjust it. I'm going to move that decimal point over so my leading digit is between 1 and 10. And that's going to be 6.5 times 10. And because I moved it to the left, that's a positive. So negative 2 plus 1 is negative 1. So those are ways to do adding and subtracting. Let's see if I think multiplying and dividing is a tidge easier. Oh, you couldn't see that in the video, sorry. Here we go. Multiplying, let's go ahead and convert these and see what we know. 3 times 10 to the 4th is 3 followed by 4 zeros. 2 times 10 to the 1st is 2 followed by 1 0. So we have 30,000 times 20,000. And we know that when we do this, we do 6 times 2. Or, sorry, 3 times 2 is 6. And then how many zeros? 1, 2, 3, 4, 5. And that becomes 6 times 3, 4, 5, 10 to the 5th. All right, so what do we notice about that? Let's do our second example and then see what we notice to see if we can make a shortcut. 6 times 10 to the negative 2 is 1, 2. Times 7 times 10 to the 5th is 7 with 5 zeros. And when we do that, that becomes 42,000, which is 4.2 times 10 to the 4th. 1, 2, 3, 4. What do we know? Well, I know that 3 times 2 is 6. So that's my leading digit. And then, when I multiply powers of 10, that's one of our rules for exponents. We're adding the exponent, so 4 plus 1 is 5. Well, that makes sense. And what happens here? Well, 6 times 7 is 42. And then if I add those, that become negative 2 and 5 is actually 3. Oh, but then I had to adjust it a little bit because 42 isn't between 1 and 9. So what do I notice? Well, this is pretty easy. We just multiply. I'm going to call them our leading digits. And then we're going to add our exponents, and that's going to determine our power. And then if I need to adjust, I will. So just adjust if needed. And that's kind of that step right there. So that's kind of our shortcut. Let's see about division, last one. Let's go ahead and convert these to standard, then see if we can notice anything for our shortcut. 8 times 10 to the 5th is 8 followed by 5 zeros. 1, 2, 3, 4, 5. Divided by, I'm going to write as a fraction, 4 with 3 zeros. And I know I'm going to simplify these. I'm going to start dividing by, here's dividing by 10 tenths, 10 tenths, 10 tenths, and I have 800 divided by 4, that is 200. And if I were to rewrite that, that would be 2 times 10 to the 2nd. So how do I get from here to here? Do you notice anything? Let's try this one. 7 times 10 to the negative 3rd, and that is, let's see, 7, 1, 2, 3, divided by 2 times 10 to that's 0.002. Basically, I can just move these over 1, 2, 3, 1, 2, 3. I'm multiplying by 1,000 thousandths, and that becomes 7 halves. which if I convert that, that would be 3.5 times 1, which is 10 to the 0 power. Let's see, what do I notice about that? It seems that all I have to do is divide my leading digits, and then because division, we are subtracting our exponents, you just subtract your exponents. So 8 divided by 4 is 2, and then I have 5 minus 3 is 2. And I didn't have to adjust that one at all, which was nice. 7 divided by 2 is 3.5. Negative 3 minus negative 3 is negative 3 plus 3, which is 0. So what do you notice? So our shortcut, well, we're going to do the same thing that we did over with multiplication. We're just going to divide our leading digits. And then we're going to subtract our exponents, and that's going to determine what power we have. And then we didn't have to do that in this case, but we might have to. We might have to adjust our decimal if necessary, if we end up with getting a number that's not in between 1 and 9. So there we have some shortcuts for addition, subtraction, multiplication, and division for keeping our answer in scientific notation. As always, you can always just translate your number into standard form and do the operation that way and convert it back. That's always a possibility, but if you can remember the shortcuts, they work as well.